Okay, guys, we're going to try something. Since the weather may be bad this afternoon, I was afraid that perhaps your Wi-Fi would go in and out. So that's why I decided to make a video. All right, then you can watch it sometime before, the next couple of days. We're going to kind of touch a little bit on this when you come to class on Monday, but not much because I've got to go ahead. So you do need to make sure that you're good with this. If something doesn't make any sense to you, then you can email me and we can set up a meeting via Zoom or in person. So what I'm going to do is I'm going to go over that last confidence interval with you about how to find the confidence interval for either variance or standard deviation. And it's a little different. It's not harder, it's just a little more work. So the calculator is not going to do it for you this time. You're going to have to do it. Okay. So I'm going to share a PowerPoint with you. Hopefully, this recording sometimes goes in and out. So we'll see how it goes. All right. So let's see if this is going to work. All right. I'm going to share my screen with you. And this is a hastily made PowerPoint. So, not very professional looking, but we'll work our way through it. Okay. So it is a confidence zone for variance or standard deviation. Now you remember when you did one for proportion with one extra step, you got percent. So the same thing's going to happen here. We're going to start out with a confidence interval for variance. So if they ask you to do one for variance, then you're finished. If they want it for standard deviation, which they seem to want more often, then you do your one more step. How do you go from variance to standard deviation? That's right. You take the square root. Now, here's my advice. Anytime you're watching a video from me, you need to have your notebook out and your book out ready, just like you were in class. Okay. And I want you to take notes as you go. So you can always pause the video and write down what's on the little slide and then, continue the video. And you can back up and go forward. All right. So let me kind of show you what I'm talking about. All right. First of all, I do want to make sure that you understand this distribution is not a normal distribution. The others were normal. So remember, they were symmetric. That hump was in the middle. All right, this distribution is called a chi-square distribution. Now, chi is simply a symbol. All right, it's this symbol right here. All right, let me see if I can get my screen to do some things. It doesn't really want to. Okay, so a chi symbol looks like an X with a little bit of a curve to it. Not that it matters, all right? But they didn't name it a chi distribution. They named it a chi-square distribution, okay? So that's just its name. You're not going to end up squaring the number that you get off the table, all right? So a couple of things about this chi-square distribution. It's not symmetric, all right? So it's a little more like a normal distribution on a bad day, all right? So that hump isn't in the middle, so it's skewed. All right, so it's skewed to the right. All right, so it's not symmetric. Now, so before, you kept having your sample data, when you were doing P, you would basically take your sample P hat and you would subtract a little bit, and then you would take that P hat, and you would add a little bit. All right. And then when you did mean, you did the same thing. You took that mu and you're looking for your population mu. So you took your sample average and you subtracted a little bit of error. And then you took that sample average and you added a little bit of error. All right. The reason you could do that is because those curves, that normal distribution curve was symmetric. All right. So taking a little bit off the left and the same off the right, works when it's symmetric. Well, this one's not symmetric. So that's why when you get to your formula in a minute, it is not going to look like that. Okay, so you might think it would because that would be, if the others, that would be similar to the others, but it's not going to look like that. Now, your book gives you a formula for chi-squared, but you're not going to need to do it. Okay, this formula they've done for you with different values and placed in your textbook in the back of the book in a table. All right. Also, if you have one of these little flippy fold out things, it's also in here. Okay. But I do want to show you something. Here's how they got the chi-squared values. All right. So what ends up happening is, N always stands for your total. And then your standard deviation squared, that's your variance, that's your sample one, and that's your population one. So the only thing I want you to kind of notice that they kind of make a big deal about in your book is these chi-squared numbers, like this is like a 0. Like you're not going to ever get negative chi-squared numbers. Remember, you could get negative z-scores, okay? But you cannot get negative chi-squared values, because naturally when you square the standard deviation, whether it's the sample of the population, those numbers are not ever going to be negative, all right? Your total, you can't have 0 people, okay? Your sample size, if you only had 1 in your sample, that'd be ridiculous. But the smallest any of those numbers could be would be 0. So your chi-squared numbers in your table are all positive. Now they say non-negative because technically you could get a 0 standard deviation or a 1 sample size, but they really kind of make a big deal about that. Okay, so all right, let me see if I can get it to stop this annotation so I can kind of go on to this second slide. So what I want you to get out of this first slide is to realize that this chi-square distribution is not symmetric. And so the formula is going to look a little bit different. Okay. Now, what about what you care about? In other words, how do I work the problem? Well, I'll get to that in just a second, but I do want to show you one more thing. They show you this in your book, but they show you now a degree of freedom. We'll talk about this a little bit more later, but a degree of freedom is this idea of kind of how much leeway you have on something. And I'll try to have time, hopefully, to explain that to you on Monday for just a second. But for working purposes of your homework, just trust me with it, okay? I don't say that very often. I'll explain more about it on Monday. But you're going to have to find something called degree of freedom. And it's simple. All you do to find degree of freedom is n minus 1. Remember, n's your total. So whatever your sample size is, you're going to subtract 1, and that's going to be your degree of freedom. Now, what I want to show you that your book kind of points out is this. This red curve is if there were like 11 in the sample. Because if there were 11 in the sample, 11 minus 1 would be 10. So that would be my chi-square distribution if I had a degree of freedom of 10. Well, look what happens when you have like 21 in your sample instead of 10 in your sample. If you had 21 in your sample, then 21 minus 1 would be 20. So your degree of freedom would be 20. Notice the curve, as the sample size increases, this chi-squared curve does start looking a little more like a normal distribution. Okay, so they kind of wanted to point that out to you. Now, to work the problems, I'm going to go over these steps. The only thing you're really going to have to find in order to complete the formula are these chi-squared numbers. So what I want you to do, I'm going to talk you through finding the chi-squared values, and then I want you to pause the video and I want you to copy that down. Okay, because you're going to need that when we go work the sample problems in a minute. And so you want to have that in notes next to you because that slide will be off the screen. So when you have to find these chi-squared values, the first thing you're going to do is draw a picture. Now, what do I mean by draw a picture? Well, what I mean by draw a picture is you're going to draw a chi-squared picture. So again, it's going to be kind of like a normal curve, but the right tail is going to be longer than the left tail. All right. Then you're going to have to find your degree of freedom, and you're going to label that degree of freedom. And the way you do that is n minus 1, your sample size minus 1. Now, let me warn you. In the table that we're going to look at in a minute, sometimes that degree of freedom is there. So if it's there, you use it, because that's going to tell you what row to look on in a second. All right. If it's not there, then you're going to pick the closest one, and you'll see when I show you the table in a minute, but it's not the Price is Right. It's not the closest one without going over. It's just the closest one. Okay. So that's an easy thing to do. You're going to be n minus 1 and label that on your paper as your degree of freedom. Now, we did go over this when we were trying to find z-scores, and the process is the same. You're going to have to find alpha first, and the way you're going to find alpha is you're going to say 1 minus your confidence level. So if they wanted a 95% confidence level, you'd say 1 minus 95%. All right, just like before, once you get your alpha, you're going to take that alpha and you're going to divide it by 2. And just like before, that alpha divided by 2 is the area in each tail. And so what you're going to do when you find alpha is you're going to go put them on the picture. And I'll show you how to do that in just a minute. Okay. Then you're going to go to table A4. So table A4 is on page 563 in your books. It's also, like I said, on this flippy fold out. So if you've got this flippy fold out thing in your book, then it's also there. All right. And so this table I'm going to show you in a minute has columns, and it has columns, columns go up and down in the building, and then it's got rows. So to know what row to be on, you're going to need your degree of freedom, which you just found in step 2. To know what column to look under, you're going to have to look at your picture with your alpha divided by 2's on it. All right. So the degree of freedom is going to tell you which row, and the area to the right of your value is going to tell you which column. Now, it tells you that at the top of the table, but notice that's a problem, because you remember when we were doing all that chapter 6, you kept having to have the area to the left, the area to the left, the area to the left. Well, this table is area to the right. So you got to be real careful that you remember that, but it does tell you that at the top of the table. So just read the table. Okay. And then you're simply going to take those chi-squared numbers and you're going to substitute them into the formula that I'm going to give you in a minute. So the only real work that you have to do is you have to find these chi-squared values. Now, when they come off the table, that's the chi-squared values. You're not going to square them. Chi-squared is just their name. Okay. Now, let me show you something on this table. All right. So turn to page. We'll do this. First, freeze this video and copy these steps down. All right, hopefully you did what I told you and you froze the video and you have those steps next to you. Okay, so when you get down there to step 5 and it says use this table, notice what happens. And it says, remember I told you, it says area to the right. Okay, so make sure that you notice that it's area to the right. Now, the degree of freedom tells you what row. So if you had a sample size, for instance, of 10, then your degree of freedom would be n-1. So you'd be on row 9 right here. So you would know that your numbers, you have narrowed it down to numbers in this row. Okay, this row 9. All right, so that tells you what row. Now, in order to know what column to look under, you have to have the area to the right. All right, so let me show you what I'm talking about with a couple of examples. All right, now you need to have your table next to you. So I need you to pause the video once you get your table and you've got your steps. All right, so get your table and your steps ready before we go to this next slide. So pause the video, make sure those steps are next to you, make sure that that table's next to you. All right, hopefully you did what I told you. Okay, so look what it says. It says, let's practice finding some chi-squared values off of your table. All right, so we're going to kind of flip back and forth between this table, and you've got your table next to you, and this slide. All right, suppose the word problem tells you that your sample has 20 people in it and that you want a 95% confidence interval estimate. All right, so when you look at your steps, it should be next to you. Your first step tells you to draw the picture. So what do I mean by draw the picture? I mean that suddenly you have this picture drawn, and now I want you to do chi-squared here. So that tail and chi-squared here. So you've got 2 chi-squared values. They very creatively named this one L for the one on the left and this one R for the one on the right. So that's why I've got a chi-squared left and a chi-squared right. So the first thing you do is you just draw this generic picture. Okay. So you got to find your degree of freedom. All right, that's step 2. So n minus 1. So if they're 20, my n is 20. So my degree of freedom would be 19. And sure enough, if you look at your table, there is a row 19. So that's the row that I'm going to use. I'm going to use row 19. Now, the next step, step 3 says you got to compute alpha. So remember, alpha, it says, is 1 minus your confidence level. So 1 minus 95% is 1 minus 0.95. So that gives me, of course, 0.05. Then, of course, the next step, step 4 says compute alpha divided by 2. So if I half that 0.05, I get 0.025. And this is the area in each tail. So I go back to my picture and I shade that area like I did here, and I label it 0.025, and I shade that tail area and call it 0.025. Now, it would bother a little kid, but you're not a little kid. Things can have different shapes, can have the same area. I can make a rectangle and a triangle that both have an area of 4 square units. They won't look the same, but the space on the inside would be the same. So though this one's taller and skinnier and this one's shorter and fatter, their areas are still 0.025 each. Okay, now it's going to be better if you draw 2 pictures in order to do this. And I don't care which one you do first. I did the one on the right first because that tends to be the quickest. So I redrew this picture just looking for this right one. So this tells me which column to use, because notice the column is the area to the right. So I'm going to go back to that table and I'm going to be on row 19 and I'm going to look under column 0.025. All right. So go back to this table and I'm on row 19. Okay. So I come down here and it's hard to see here, so you need to be looking on yours. Okay. So I'm on row 19. So I know that it's got to be one of those numbers right there. I've narrowed it down to those numbers. Now remember, I'm under the 0.025 column. So I come up here and look for 0.025. All right, and that 0.025 is right there. So I'm in this column. So what I'm looking for is I'm seeing where this row intersects this column. Where they intersect, that's the number that I need. All right. So that's how I know that that number is 32.852. All right, so it's hard to see on the screen, but look on your table where row 19 intersects that 0.025 column, you should see a 32.852. Okay. So that's why right here I have 32.852. All right. Now, how do I find the one on the left? Well, now notice what happens. Okay. I know that this area right here is 0.025, but I don't need that area. I need the area to the right. So how did I get 0.975? Well, I said all of it's 1, 100% is a 1. So 1.00 minus 0.025 gave me 0.975. So now I'm still on row 19, but this time I'm on column 0.975. All right, so I'm still on this row 19, but now I'm in a different column. Now I'm on 0.975 column. And those two intersect right there on that number right there. So that number is 8.907. All right, so are you able to see that that's 0.8907? So that's why that's going to be my chi-squared left number in just a second. Now, I will tell you this. The author did try to at least do this to help you a little bit. He made the columns go from outside in. And by that, here's what I mean. When you're going outside in this way, The column you needed the first time was third from the right. So its partner is 1, 2, 3, third from the left. So if one of your numbers is 2 from the right, its partner is going to be 2 from the left. But just do 1 minus that and you'll have it. Okay. So let me go back. So that is why right here, I have 8.907. And then the left one, of course, goes on the left, and the right one, of course, goes on the right. Okay. Now, I'm going to let you try it. Oops. All right. And then see if you get the same thing. What if your sample had 45 people and you had a 90% confidence interval? So why don't you pause it in the video and try it by yourself with your table, and then come back and see if you've got the same answer. So freeze the video for a second and go work on it, and then come back. Okay, hopefully you did what I told you and you froze it. So let's double check and make sure and see if we agree on the same answer. Okay. So your sample's got 45. So 45 is your n. Remember, your n's your total. Well, 45 minus 1 is going to give me 44. So my degree of freedom is 44. But if you go look on your table, you don't have a row 44. So you had to pick between row 40 and row 50. And 44 is a little closer to 40 than 50. So pick 40. Now, if it had been 48, 48 would have been closer to 50, so I'd have picked 50. Now, the only time it's going to be a little weird is when it's 45, when it's really the same from one to the next. Usually they do what we do. They just go ahead and go up. All right. So if it were 41 or 42 or 43 or 44, they're closer to row 40 than row 50. If it's 45, 46, 47, 48, or 49, they would say it was closer to 50 and use row 50. So if it's there, like up here, when it was row 19, use the row, if row's there, use it. If it's not, use the closest one. I'm not going to make you interpolate the table. I could, but I'm not. You're welcome. All right. So I'm going to use row 40. Now, what do? I had to draw my picture. I had to go find my alpha. Well, 1 minus 90%, because it was a 90% confidence level, gave me 0.1 or 0.10. When I divided that by 2, I got 0.05 500ths. So that's why that tail area was 0.05 and that tail area is 0.05. So here's my left one and here's my right one. But I redrew the pictures separately so I didn't get confused, because to read the table, I need the area to the right. So do you understand that this tells me what column and this tells me what row? So I was on row 40 under the 0.05 column. All right, row 40 under the 0.05 column. All right. So row 40 is down here. So I'm on that row. And I'm under the 0.05 column. All right, so that 0.05. Now be careful, because there's also a 0.005. So don't be glancing at it. Don't grab this one when you really need this one. Now, what number is right there where they meet? All right, so row 40 under the 0.05 column should have been 55.758. So is that what you got? Okay. So that's why I got that 55.758. Now, where did I get this 0.95? Well, remember, if there's 0.05 to the left, 1 minus that gave me the 0.95. So when I looked on row 40 and I looked under column 0.95, I got that 26.509. So if you can't find the numbers on the chi-square table, you need to email me and let's set up a quick Zoom meeting. All right. Now, assuming you can find the chi-squared numbers, the rest is a piece of cake. All right. This formula right here is on your formula sheet. This is your formula to find the confidence interval for variance or standard deviation. So you don't have to memorize it. It's on your formula sheet. So make sure, go find your formula sheet and make sure you see it. So I want you to turn to page 340 in your books and look at problem number 10. So freeze the video while you get that one. Okay, hopefully you're back and you're on page 340. Problem number 10 says this. In a test of weight loss programs, 40 adults used the Atkins weight loss program. This should sound familiar. After 12 months, their mean weight loss was found to be 2 1/10 pounds, or the standard deviation of 4 8/10 pounds. It says construct a 90% confidence interval estimate of the standard deviation of all the weight loss for all such subjects. All right, so as soon as it tells me, all right, to do a confidence interval, I go underline of what, and it said of standard deviation. So I go to my formula sheet and I copy this formula right here. That's the first thing I do, is copy that formula down. Now notice, N stands for your total, S stands for standard deviation. So the only thing you're missing are these chi-squared numbers. And remember, this is the standard deviation of a population. That's what sigma is. So sigma squared is the variance. So this is a formula for variance. Okay. So if we want to do standard deviation, can't write with this little thing. All right. That's sad, isn't it? So that's one for variance. We're going to do one extra step in a minute. So the first thing I do is fill in what I know. I know N is 40, so N went to 40. The problem told me that my standard deviation was 4.8, so I've got to take that 4.8 and I've got to square it. And notice the numerator over here is the same as the numerator over here. Okay, so make sure we're clear about that. So the only thing you got to go figure out are these chi-squared numbers. Now, how do I do that? Go back to your steps to find chi-squared numbers. So the first thing I did was find my degree of freedom. So 40 minus 1 was 39. Well, I don't have a row 39. On my table, I've got a row 30 and a row 40. So is 39 closer to 30 or 40? 40. So even though my degree of freedom is 39, I'm going to use 40 for my row. All right, so I'm going to use 40 for my row because I don't have a 39. Okay, then I get my alpha. 1 minus 90% is 0.1. When I divide 1/10 by 2, I get 500ths. So this tail area right here is 500ths, and this tail area right here is 500. So I've got to find the left one and the right one. Don't care which one you do first. So I did the right one first because I've already got the area to the right. So this tells me to look under the 0.05 column, and I'm going to be on row 40. So when I did that, that was my number. That should look kind of familiar to you. Okay. Then I had to go find the one on the left. So I know that that area right there is 0.05, but I don't need that. I need the area to the right. But 1 minus 0.05 is where I got the 0.95. So I'm still on row 40 on my table, and I'm under the 0.95 column. So freeze it and make sure that you agree that those intersect where the number is 26.509. So make sure you can find these chi-squared numbers. Now let me warn you about something. You need to pay attention. I'll tell you why in a second. I want you to notice that on the formula, the right one is on the left side and the left one is on the right side. So don't grab this left one and put it on the left and grab this right one and put it on the right. Read it. The L one goes here and the R one goes there. So that's why this left one, all right, is right here. And this R one, see, R goes right there, is right there. Okay. Now, we'll follow your order of operations. I did my parenthesis. So 40 minus 1 was 39, and I squared my standard deviation. Same thing happens on the right side. Now, I multiply these two and got 898 and 5600. The same things on both sides. I divided those two numbers and just rounded to, about a few decimal places. Now, if it had said find a confidence interval for variance, I would be finished because sigma squared is variance, but it said find a confidence interval for standard deviation. So how do you go from variance to standard deviation? I had to take the square root all the way across. And the square root of sigma squared was just sigma, the symbol for standard deviation. The square root of this 33 point number was about 5.82. The square root of this 6 number was about 4.01. So usually I go to one more place of accuracy than my original data. So because they rounded to the tenths, I went ahead and rounded my answer to the hundreds. Okay. So do you understand that the only thing that you have to find these chi-squared numbers and be careful. Now, let me just, for your sake, let me tell you why he did it this way. All of your other confidence intervals have less than. P is less than numbers. Mu is less than numbers. Okay, well, think about fractions. The numerators are the same here. So if you had a 2 over a 9, or if you had a 2 over a 3, what's bigger, 2/9 or 2/3? All right, do you know that the smaller the bottom number, the bigger the fraction? Okay, 1/2 is a lot bigger than 1/10. Half a pizza is a lot more than 1/10 of a pizza. So when the bottom number is bigger, the fraction is smaller. That's why the bigger bottom number is here, because when the bigger bottom number is here, the whole fraction is smaller. And that way he could have this still be less than, just like these are less than. So if he'd have put the left one on the left and the right one on the right, these would have had to have gone to greater thans, and he thought that would freak you out. But just read it and you will be fine. Okay, so this formula right here comes off the formula sheet. The only thing you got to find are the chi-squared numbers. Now, you do have to square your standard deviation, but do not square these chi-squared numbers. That's just its name. Okay, so I'm going to give you some homework on Canvas. All right, if you have trouble with it, then you need to email me. I don't think you will. It's pretty straightforward. All right. So let me kind of stop sharing. So you got some homework. So that kind of finishes chapter 7 for you. You have to do confidence intervals for proportion, percent, for mean, and for variance and standard deviation. And the main thing when you're reading those problems, those word problems, when it says construct a confidence interval, underline of what? Because if I tell you to do one for variance or for standard deviation, and you go do it for mean, you won't get any partial credit. So just that little underline is going to make your life a lot easier. Okay, so stay safe. Hope you have a great day.